Okay, we are now on lesson 5. Topic is motion in one dimension, free fall, part 1 out of 3 lecture videos. Let's proceed. Okay, so for this topic, we have actually 6 subtopics. We have to define what's motion in one dimension in terms of free fall, the conceptual perspective, and so on and so forth. This would be for part 1 of this lecture video series. For part 2 of the lecture video series, we're going to have problem solving. We are to search for velocity and time, and the maximum height an object thrown at a free fall will or can um, achieve. For part 3, you're going to be given problem examples or example problems in terms of free fall. Okay, so let's define first what do we mean when we say free falling objects or free falling bodies in a uniformly accelerated motion. So simply defined, a free falling body is defined as a body or an object that is moving under the influence of gravity. It is assumed that the effect of air resistance is negligible, and the motion of any falling object is found to be under a constant acceleration, which is due to gravity, denoted by a small letter g. So gravity, also called little g here, small letter g here, is a very fundamental physical force that is responsible for interactions which occur because of mass between particles and between aggregations of matter. It can also be defined as the force that pulls an object towards the Earth's center. The value of object's gravity depends on its mass, but we are to use 9.8 meters per second squared in our next few problem solving examples. To define further free falling objects, the magnitude of a free falling object or the magnitude of the free fall acceleration decreases with increasing altitude, meaning as you go further away from Earth, your free fall acceleration will decrease. This is also varying depending on the latitude. For short, if you're closer to the Earth, your acceleration due to gravity would be higher. And if you're further away from the Earth, your acceleration due to gravity would be lower. However, for problem solving purposes, we are to approximate the gravitational force or the acceleration due to gravity as 9.8 meters per second squared. So ito yung usual nating gagamitin. This vector is directed downward toward the center of the Earth. For short, we are to use acceleration as its vector counterpart. Okay, so in addition, we have here the formula for example for velocity. And what we're going to have to remember here is that since we are now talking about gravity as a vector quantity, we also have to take note of its direction. Since acceleration due to gravity is always downward, when we try to compute for acceleration, instead of inputting 9.8 meters per second only, we have to write down a negative value here before its number. So it will now be negative 9.8 meters per second squared. Okay, since gravity again is going downward. When we now talk in terms of velocity, okay, we are now talking about also a vector quantity. Meaning, for example, when you free fall an object, for example, we have here a ball and then you just drop it, it will have a certain velocity downward. Okay, so if the velocity is downward, we should input here a negative velocity. If you have an object thrown upward, the magnitude of the velocity would be positive. Okay. Now, We're now going to focus on the different equations of kinematics. Last time we have defined the equations of kinematics in terms of motion in one dimension. However, we are focused on the x dimension. For short, we talk about bodies, for example, a car moving in the x dimension, at an LRT moving on an x dimension. This time, we are now to focus on bodies which are on the y dimension. So these formulas here are equations of kinematics in terms of x dimension. However, since they are still equations of kinematics, we can still use them in terms of the y dimension. We just have to change a few values here. For example, when we talk about velocity in the f, we are now to write here a subscript y, Since we are now going to talk about velocity or the final velocity specifically on the y-axis. So medyo madadagdagan siya. And the initial velocity will now become initial velocity in the y-axis. Plus, this time, since we are now talking about acceleration due to gravity, instead of writing a, we write it down as g, and t, of course, would still be t for time. Now, one thing to note is that since every time we talk about acceleration, we are talking about acceleration due to gravity, which means that g in free fall is always given as 9.8 meter per second squared. So kindly take note of that. So unlike the motion in x dimension na hinahanap pa natin yung ating acceleration, this time it will always be given as 9.8 meters per second squared. So medyo mas mapapadali yung buhay natin dun. Okay, so let's now talk about this formula. This talks about motion in one dimension in terms of the x-axis. So if we are to talk about the position in terms of the y-axis, this will now change into yf is equal to yi plus velocity, initial velocity in the y-axis multiplied by time, because time is time no matter what, plus 1/2 acceleration due to gravity time squared. So this is now your formula when you talk about free fall. So now go to the third formula, same. Instead of yf or minus, instead of xf minus xi, it will now be yf minus yi is equal to 1/2 velocity f in the y-axis minus velocity I on the y-axis multiplied by time. Again, this formula is just an additional for you. This is not usually used. For the fourth formula, we have here Vf. So this will now be Vfy squared is equal to Viy squared plus 2. Instead of A, we write it as G. And the change in position will now be delta y, or the change in the position y. Okay, so that's how you do it. So to summarize, this will now be your... So since we have converted a while ago the equations of kinematics specifically for y dimension or free falling objects, these are now your new formula. As you can see, pareho lang din naman ng equations of kinematics in x dimension. Pinalitan lang natin specifically for y's, and we have changed acceleration into letter G to denote that we are accelerating due to gravity. Okay, to furthermore discuss free falling objects, we're now going to look at it in terms of a conceptual perspective. Let's analyze. Okay, so what do we mean when we say an object which is free falling? It means that the acceleration of a free falling object is constant, which means that the velocity of a free falling object changes at a constant rate. So since we are talking about gravity, which is about 9.8 meters per second, and let's just let's just say that that would be 10 meters per second squared for the sake of clarity only, para lang mas madali nyong makita in terms of this table. So stated here, the velocity of a free-falling object changes at a constant rate. And that constant rate is, of course, the rate it in as it travels through time. So from 0 to 7 seconds, as you can see here, you have 0 and then it becomes 10, 20, 30, 40, 50, 60, 70. And that is an interval of 10 meters per second squared per 1 second. So you have here an example. You have a man on a ledge and then it tries to free fall a ball. So it just drops or binitawan niya lang. So if ganon yung situation, your initial velocity would be 0 meters per second. And about 1 second, the velocity now for 1 second should be 10 meters per second since it's accelerate at about 10 meters per second squared. For about 2 seconds, its velocity will now be 20 meters per second. So there's a 10 meters per second increase. Again, why? Because of the acceleration due to gravity. At a velocity at 3 seconds, you're going to have 30 meters per second. And then from the moment it reaches the ground, you're going to have 4 seconds. That would be 40 meters per second. Okay, so that's what we mean when we say that it is accelerating at a constant rate of gravity. Now, if you are asked, for example, what is the interval between this position, this position, this position, and this position before it reaches the ground? Gaano kalayo yung x1, x2, x3, and x4? Okay, so by looking at this one, and then usually you're going to say that it's 10 meters per 10 meters since the velocity is 10 meters per second. However, it would be incorrect. Why? Because 10 meters per second is actually the final velocity. In addition, this should be negative 10 meters, negative 20 meters, negative 30 meters, and negative 40 meters since your velocity is actually going downward. So, pababa siya in terms of our position. Okay, so what is now the interval here in terms of position? For that, we need to search for the average velocity. And how do we search for the average of something? So just add the value here, then divided by 2. So that would be 10 divided by 2. You're going to have 5 meters per second as your average velocity for this interval. And you just add here a negative sign denoting that's going downward, which means that the interval here is not 10, rather it should be 5 meters. Next, for situation 2, if you're going to search for the interval, that would be the 10 plus 20, that would be 30 divided by 2. You're going to have the average here as 15 meters per second. And just input negative to denote that's going downward. That will now be 15 meters. For the third scenario, that's 20, 30. That will be 50 divided by 2. That would be average velocity of 25 meters per second negative. So that means that for position 3, you have reached about 25 meters. And then for situation 4, you have 30, 40, that's 70 divided by 2. You're going to have 35. That's the average velocity here would be 35 meters per second, and that should be negative to denote that's going downward, which means that for x4, it actually reaches 35 meters. Now, if you're going to look at the meters here, as you can see, it's actually increasing, and that would make sense because from time 1 second to time 2 seconds to time 3 seconds to time 4 seconds, mas bumibilis yung pagbagsak ng bola. And bakit mas bumibilis? Again, that is because of the acceleration due to gravity. Okay? Just a disclaimer, we just use 10 meters per second squared here to just illustrate what we mean when we say a free falling object. But for our next problem solving, we're going to use 9.8 meters per second squared, specifically negative 9.8 meters per second squared. Okay, that's it. For our next video, we're going to learn how to problem solve using the equations of kinematics and free fall for some specific problem examples.